Hey folks, today we have a math refresher on 4 topics that are seen very frequently in about grades 6 through 7. And this video is going to be a bit long because I'm going to work out the examples with you. But if you want to just jump to any of these 4 sections, go ahead and scroll down on this page and you should notice that there are little links that will let you jump ahead so you don't have to watch the whole thing. I made this so that every one of my students can follow along and see, because I don't want them to think there's any magic going on, so we work everything out thoroughly. I still try to speed it up though, so for some of you it may be fast. If it is, we go ahead and freeze it. Otherwise, let's go ahead and continue. So as you can tell here, we have first, we're going to start on area and circumference, and we're going to work on simple right triangles. We're going to do a couple of very simple word problems and some of the logic. And what's going to take up about a little more than half the video will be the statistics. And this is very critical. Too many people do not appreciate how important this will be later on in your math careers. Trust me, you will need this. So let's go ahead and first of all, let me see. Okay, grade 6, 7. Okay, so let's go on to our first one. Okay, we're going to begin with circles, and let's go ahead and now the 2 most important things you will want to know about a circle are its circumference. As you know, that is the distance around the circle, and we also want to know its area, and of course that is everything that is inside. And the formulas, I mean, these things are so easy you should never have to memorize them. But, let me go ahead. For the circumference, it's just going to be pi times the diameter, whereas the area is going to be pi times r times r. Now this, if you know, the diameter is just twice the radius, so we usually just stick to radii, so that's 2 pi r. And this one's pi r squared, which if you think about it should make sense. Okay, so keep these in mind. Now, if you don't know which one is which, just remember, areas usually have some sort of a squared component in them. So that should really make it easier for you to remember. Pi r squared, that must be an area. Okay, 2 pi r, circumference. You do this enough and you will never forget, so you really shouldn't have to memorize. Okay, so let's go ahead, and this says our diameter is 25. So that means that our radius, our radius is going to be 25 over 2. Well, our area is pi r squared, and that means that it's 3.14 times 25 over 2 squared, and that's going to be 25 times 25 is 625. You'll do it on paper. I just kind of know it because I've worked with it enough. And so 3.14, 625 over 4. That's going to be 1, 5, 6, 2, 5. 156.25. So now, let's go ahead and multiply those two. 3.14 times 156.25. If you wonder which order, it doesn't matter. Whichever one you prefer or makes it easier. Now let's not forget we have 4 decimal places here. So, okay, so 5 times 4 is 20. Okay, 0, 5. Okay, 625. And then this is 0, 5, 2, 6, 5, 1. Okay, 0, 0, and then 5, 0, 1, 7, 8, okay, 6, 4. Okay, so we've got 0, 5, 2, okay, 1, 16, okay, 0, 9, 4, 90. We have 4 decimal places, so that's 490.625. Since we only want the nearest whole, it's going to be 491. Okay, now circumference. Left this last because it's easier. 2 pi times the radius. So that's just 2 pi, Well, actually we can just cancel out the 2's, leave that as 25 times 3.14. Okay, and that's going to be 0 to 7 and 57, then 0, 8, 2, 6. Okay, and that's going to be 0, 5, 8, 7. And so with 2 decimal places, that's going to be 78.5 or 79. Okay, let's move on to the next one. So let's go ahead and draw our circle here, and a diameter of 22, which gives us a radius of 11. So let's figure out the area, which is pi r squared, and so that's 3.14, and that's 11 squared, which is 121. So let's go ahead and multiply this out. We have 2 decimals, let's not forget that. 314, that's 8, 2, 6, 0, 0, 4, 1, 3. It's a 4, that's a 9. Okay, the 9, 7. Okay, so that is 379.94 or 380. Now the circumference, simple, 2 pi r, so that's 3.14 times 22. That's 826, 0, 826, 8, 0, 9, and 6, 69.08, so that's going to be 69. Okay, we're on a roll. Let's go ahead and go to our simple right triangles. And all right triangles have a little right. We have our A, our B, and our C. And our formula is the Pythagorean, c squared equals a squared plus b squared. Now, please remember this critical rule. C must be the hypotenuse. It cannot be anything else. If you try it with anything else, it will fail. Okay? Now, in case you forgot what the hypotenuse is, the hypotenuse is just the side that is opposite the 90-degree angle. So let's go ahead and set this up. Once you've got C, you know that it's the hypotenuse. A and B can be whatever you want. So this time we'll just make them, here we go, 3 and 5. So C squared equals 3 squared plus 5 squared. And that gives us 9 and 25. And that gives us 34. So we root C and we root 34. And C equals, let's see, well 34 is 17 times 2. I do this just to see if there's any factors, but there aren't. So we just use a calculator. If you don't, I would just be okay with leaving it with its factors. So let's try the next one. And here we go. Okay, and that's going to be 8, 9, and C. Make sure it's the hypotenuse. So C squared is a squared plus b squared, and that's going to be 8 squared plus 9 squared. That's 64 plus 81. And that is going to be 155. And that's going to be the root of 35 times 3, 31 times 5, I think. It doesn't really matter. So the approximation is about 12.45. Okay, so here we go. So these are our hypotenuses, and notice, just to double check, they are the longest side, which is what they should be. The hypotenuse is not only the side opposite the right triangle, but it's the longest side. Okay, so we're doing great. Let's now go on to simple word problems, and that's multi-step problems. Now, let's not forget the typical strategy for word problems. First, read the problem, and of course identify the values, and then we exclude any extra values, and of course let's look for the answers. Okay, if we add, if it's a percent, a ratio, or an expression. So let's go ahead. In this case, we have 32 tulips and 46 roses, and we have 27 used. Now let's set it up. So what are they asking for? Well, we're asking for extra flowers. So these two together would be the total that they picked, and the total minus the number used should give us how many extra flowers, right? Or otherwise our solution. Simple enough. The math is super simple. What I want you to get here is the logic. So let's go ahead, and this is just 78 minus 27. So that's 5, we've got 51. So, like I said, super simple, but that's not the point. Get the logic, okay? Let's try another one. So here we have that in the round 1, we got 12 points. Round 2, we got 32 points. And in the final round, which I'll just call round 3, she lost 33, so don't forget that minus. So how many points did she leave at the end of the game? Well, at the end, it's just going to be the sum of all 3 numbers, right? So if the sum is plus 12, plus 32, and minus 33, that's just 12 minus 1, which gives us 11. Pretty simple, huh? These are fun. Let's try one last one. Okay, while shopping, Katie bought 44 green towels and 13 white. And she gave the mother 47. Okay, so let's go ahead, and first we've got the green, we've got the 13 white. Okay, and we are asked how many towels did Katie end up with? So that's the total towels that she bought, minus the ones that she gave to her mother, should give us our answer, what she ended up with. Again, look at the logic. The math is super simple. It's the logic that I want you to get. 757. It's 57. And then we have 37. We go ahead and end up with 10. So, simple enough, right? Okay, we're now going to move to the more challenging one, and that is the basic statistics. So let's go ahead, and first of all, this is a very important part of what we're doing here, so you really need to pay attention here, okay? And we're being asked for 4 things: the mean, the median, the interquartile range, and the mean absolute deviation. Okay, and let's go ahead and just refresh. The median, or the mean, I'm sorry, is the average. The median, always look at the word. If it has the D, it's the middle. So that should remind you, in case you don't know the difference between mean and median. The interquartile range is just a range between the maximum and the minimum of the quartiles. We'll go over it in just a bit, okay? For right now, just remember the quartiles are the 25th, the 50th, and the 75th. The interquartile is the distance between the 75th and the 25th, okay? We'll go over that in just a bit, so don't get too threatened here. And the mean absolute deviation, which is the most complicated one because it puts together everything. It puts together the mean, we have the absolute, and we have the deviation, and that's just that everything, we measure the distance of everything from the mean value, or the average. Okay, so since 3 of our 4 values have something to do with quartiles, let's go ahead and introduce the concept. Now, quartiles, basically what they do is your set of numbers. They split it into equal groups. Kind of like the way your ruler is split into fractions. quartiles will split your number, your set of numbers, into 4. So imagine this is an entire set of numbers. This splits them in half, so this is the median. If we do this again, notice we split it into 4 equal sets. We have quartiles 1, 2, and 3, and that gives us 1, 2, 3, and 4. Okay, so simple enough. Well, let's go ahead and take it up another level. This time we have a number line with 10 digits. Let's go ahead and write it. And let's see, can you use your intuition to figure out where the middle value should be? Okay, well, if you look at it, if you were going to just split these down the middle, you should notice that we get right here. Okay, and that's kind of curious because it's not 5. 5 is half of 10, right? But look, it's 5.5, the number between 5 and 6. Because look here, we have 1, 2, 3, 4, and 5. We have 5 numbers on this side and 5 numbers on that. And that's what a median does. It splits both in half. So let that sink in intuitively, okay? Because we're going to do this again. And this time, how do we split them? Well, this time if we split them right here and right here, so we have quartile 1 is 3 and quartile 3 is 8 and quartile 2 is 5.5. Well, now look, we've got, how many numbers do we have on each group now? Well, we have 2 here, 2 here, 2 here, and 2 here. Those are 9, 10, 6, 7, 4, 5, and 1, 2. As a matter of fact, notice I was excluding some numbers. So I want you to notice this. This you may want to remember at the beginning, although it should make sense if you use your logic. And that is, first of all, when a split cuts a number, exclude it. So notice, our quartiles 1 and 3, they cut a number, so we excluded them. And when a split does not, in any other case, keep the number. Now this is not some crazy fancy rule. There's a very good logic to it, and we will see it over the next few exercises. Okay, so let's practice a little more, okay? First off, let's get a set of numbers here. We've got 4, 10, 12, 13, 14, 18, and 20. How many numbers do we have? Well, we have 7, and that's odd. Now, I'm going to give you a little formula. You really don't need it. You can use your logic, but if you want the formula, here it is. So n plus 1 over 2 will give you the median number. So in this case, if we have 7 plus 1, that's 8 over 2, that's 4. So the fourth number is the median value. So that means that 13 right here cuts down, and by rule 1 we exclude it. Okay, so to do our next cut, we're going to do 3 numbers because we excluded the middle one, remember, and that's an odd number, so we say 3 plus 1, that is over 2, that's 4 over 2 is 2, so the second number. So we go from the extremes, so 1, 2, 10 is quartile 1, and then 20, 18, that's quartile 3. Since we cross, we also exclude them, and that's quartile 1, quartile 2, and quartile 3, and quartile 2. Good to go. Now our interquartile range is just the difference between them. Now, even though we cut them out, we still use those values for calculating, okay? So don't just trash them. Those are just, we cut them out only insofar as we are going to be determining what our medians and means are. So here, our distance is 8. So let's try it again. This time we're going to do it with evens. Okay, so now we've got 2, 7, 7, 9, 10, 15, 20, and 23. That is going to be 8. Okay, and that means that we've got even, and 8 plus 1 over 2. It's going to be 9 over 2, or 4.5. Notice we do not have an even number. That means we are not going to cut a number. We're going to go between them. So 1, 2, 3, 4, 4.5 would be right here. Okay, 4. Notice, on both sides we have 4s, so that works. Remember, our point is to split it evenly, and that's what it did. Each time that we do these steps, notice that we are splitting these things evenly. That's always our goal. Now, since this one didn't touch any numbers, remember Rule 2 says you keep all the numbers. Okay. Now, let's try it again. This time we have 4. We're even again. So that is 5 over 2, and that's 2.5. Once again, we are going to split between numbers. So that's going to be right about here, and right about here. And once again, notice we have everything split evenly, right? Quartile 1, 2, and 3. Here we have 2. Here we have 2. Always check to make sure that everything is split evenly. And 2. Fantastic. So our interquartile range... Wait. Well, if we're split between... Well, that just means that we have to get whatever value would be between those two, the average value. Okay? So if your quartile, okay, if it falls between those two numbers, get the average. Now, you don't really need to memorize this rule, because if it splits a number, it should make sense that if you get its average, it's still going to be the same value. So if you really think you're going to forget, just always try the average. When you split the number, it's always going to be the same number. Like here. Quartile 2, 9 and 10 over 2, that's 19 over 2, that's 9.5. For quartile 3, that's 15 and 20 over 2. That's 35 over 2. That's what, 17 and a half? Yeah. Okay, now we have enough to get our IQR. And that's 17.5 minus 7. And that's going to be 10.5. Fantastic. Let's go do some exercises. Okay, so let's go ahead and try with a real exercise. Now here, we have a 1, 8, 1, 4, 2, and the first thing we do is we set them in order. 1, 2, 4, 8. Do not forget this step. You'll make big mistakes if you do. Okay, so we already kind of know that it's probably going to split down the middle here, but let's do the math here. Now, our third number is the median, and if we have it split evenly 2 and 2, that means that we have 3 over 2. Again, we're going to have 1.5. So that's going to split right about here between these. It's quartile 1 and quartile 3. Okay, so far we have the mean, which is 1 plus 1 plus 2 plus 4 plus 8 over 5. And that's 16. Yeah, 16 over 5. And that's going to be about 3.2. Now, the median, well, that's just the second quartile. So that's just 2. We already got that. The interquartile range, quartile 3 minus quartile 1, the distance between those two. So let's get that average. And this is 4 plus 8 over 2. That's 6. 6 minus 1 equals 5. Okay. Remember, the IQR is just telling us the distance between these, and we'll need it later. Now, the mean absolute deviation, it's put together with a lot of operations. That's why it looks kind of complicated. What it kind of is it's the sum of the deviations, the absolute value of, over the total number. So let's do a few just so you get the idea, okay? So let's go ahead and start. Since our mean is 3.2, 3.2 minus 1, our first value. 3.2 minus 1 again, our second value. 3.2 minus 2, our third value. 3.2 minus 4, our fourth value. And, 3.2 minus 8. Doesn't matter the way you do it, you're still going to get the same. And remember, these are absolute values, which is why we have no minuses. Now, these are what we call our deviations from the mean, because they're all the differences from the mean, right? 3.2. Okay, let's go ahead and add them all up. 2, 1.2, 0.8, 4.8. Okay, and that's 11.2. So we have the sum of the deviations in absolute value. That's 11.2 over 5. Okay. Let's do a little division here into 11.2. That's 2, 10, 12, 2, 10, 24. Okay, so our value is 2.24. So let's go ahead and see our mean, our median, our interquartile, and our MAD. Fantastic. Okay, let's try it again. So this time, our values, 2, 8, 1, 7, and 4. Now let me give you the steps if you really need steps, but you really shouldn't. So first we organize them. Next we get the number, which is 5 here. And we get the median, which is just 5 plus 1 over 2. That's going to be 3, split down the middle. Quartile 1. Going to be 3 plus 1. Okay, 1.5. Quartile 3 is the same thing. Okay, so quartile 1 is 1 plus 2 over 2. So that's 3 halves. 1.5. Quartile 3 is 7 plus 8 over 2. That's 15 over 2. 7.5. Okay, so we have our 3 quartiles. And our mean is 1 plus 2 plus 4 plus 7 plus 8. It's going to be 22 over 5. 5 into 22. That's 420. 20 again, 4.4. Okay, so our mean is 4.4. Now, our median is 3. Our interquartile range is Q3 minus Q1. So that's 7.5 minus 1.5, and that's just 6. Great. Okay, now, to get our mean absolute deviation, 2 steps. First, we find all the deviations from the mean. And remember, our mean is 4.4, so that's 4.4 minus 1, minus 2, 4.4 minus 4, 4.4 minus 7, and 4.4 minus 8. And remember, that's absolute values, so these are positive 2.6 and 3.6. Now we add these all up. That's going to give us 4. And that's 2, 12. 12.4. Okay, so we find the mean, and that's going to be 12.4 over 5. And that 5 into 12.4, that's a 2, 10. Okay, 4, 20, 40, 2.48. So our mean absolute deviation is 2.48. Now, let me go ahead and give you a little more graphical understanding of what this mean absolute deviation is doing. Okay, so first of all, let's get our number line here. And let's get all our values, since we had all the way from 1 to 8. So we have 0, okay, we have 8. So this will be 4, this will be 2, this will be 1. Okay, so we've got 8. Okay, so our median, or our mean, was 4.4. Okay, and then we had a value of 1. So we had a value here, we had another one here, we had a value of 2, okay, 7, and 8. And so what we were doing is we were just getting the distances of each of these. Okay, so that was 3.4, that was 2.4, and that was 0.4. And our other distance was 2.6 and 3.6. And these are related to a concept that we talk about that is called the variance and the standard deviation. It's a simplified version, and that's why we introduce it now, because the variance and standard deviation are a little more complicated. But it's best to start here, because in statistics, the two most important values are going to be, number one, of course, the mean or the average, and number two, the variance. Okay? And that's because with these two numbers, you can literally describe any population of numbers pretty close. So that's actually an amazing property these two features have. So you really want to start practicing, because trust me, you will use it. So anyway, I hope I wasn't too fast there. If I did, just go ahead and freeze it and go over anything I was a little too quick about. Any questions? Go ahead and let me know. Okay, thanks, and take care. Bye.